All right, our next chapter is over squares and rhombus. A square and a rhombus are very, very, very alike. The only thing that separates them are a couple of properties. So that's why we combine them together. But you'll see that the properties kind of line up with parallelogram and another shape. Or it's a combination of like 2 or 3 shapes or quadrilaterals. So just be mindful of that. As we go over the properties of rhombus, the highlighted ones are the newer ones. So the first 5, opposite sides are parallel, opposite angles are congruent, opposite sides are congruent, diagonals bisect each other, and consecutive angles are supplementary. Those are the 5 properties that parallelograms have. And if it's a parallelogram, then it has those 5 properties. And a rhombus is considered a parallelogram. So that's why the first 5 properties are always going to be the same. Okay. So what separates a rectangle and a rhombus is that all 4 sides are congruent. Diagonals are perpendicular. So here's what I mean by diagonals are perpendicular. So when I create a rhombus, I'm going to do my best. Kind of looks like a parallelogram, but all the sides are the same. So it's really hard to determine if the sides are the same. But when I create my diagonals, where they meet, they're perpendicular. So they create 4 90-degree angles. Okay, so that's super important to know because then now you essentially have 4 right triangles along with your rhombus as well. So like your rhombus itself. So that kind of plays a part into it. And then also just knowing that these are 90-degree angles will help us determine the side or these lengths if they ask for it. Okay. And then the diagonals bisect opposite angles. So not only do the diagonals create perpendicular angles in the middle of the rhombus, but each angle is actually split in half. So they're congruent to each other. Well, so the opposite angles are congruent, but they're also bisected by the diagonals. Okay. So those will be important as we go into the questions. So example 1 says that RST is 67 degrees. So if I follow those points, I have R, I hit S, and then I go to T. It's that whole angle. So all of angle S is 67 degrees. I want to find RSW. So if I follow those points, RSW, it is only this part of this angle. So if RST is the whole angle and RSW is part of that angle, we need to go to our properties and see how we go about solving this. So one of our new properties is that the diagonals bisect opposite angles. Okay, this will help us. So if the angle I want includes the diagonal, then that means that that diagonal split that 67, that whole angle, in half. So the rule I'm going to use, the property I'm going to use, is that diagonals bisect angles. Okay, so I need to take my whole angle, which was 67, and divide it by 2. Because the angle I want to find is part of that whole angle. And that diagonal cut it in half. So it's 33.5. All right. Example 2 says find RTV. So find RTV. So let's go RTV. So we have RTV. Okay, so it's that little part. This little part right here. Again, a half. Okay, but it gives me the value of RVT. So RVT. So it gives me the whole. Okay, well, the whole value of RVT is 135. So there's going to be 2 steps we do here. So I need to figure out what I need to do to even find angle T. Because if I know all of angle T, I'll know I can find half of it. Okay, so I got to find all of angle T first. So, and how we're going to do that is our old parallelogram rule that consecutive angles are supplementary, meaning they add up to 180. So in order to find all of angle T, I need to subtract. And the reason I know they're consecutive angles, by the way, I'm going to backtrack. Angle V and angle T are next door neighbors. Okay? They're 2 different sizes, so I know that they'll add up and equal to 180. So I need to take that 135 and subtract it from 180, and I'm left with 45 degrees. So this means that all of angle T equals 45 degrees. But I only want part of it. Well, again, let's go back to our rule, our new rule we learned today, that diagonals bisect the angles. Okay, angles. So in order to find a part of that angle T, I need to take that 45 and divide by 2. And that's where I'll get 22.5 degrees. So notice how there's a rule for every step I take in how I solve these problems. All right, example 3. Find SRV, angle SRV. So SRV, so I want to find a whole. It gives me the value of WRV, so that angle. And then WRS, so WRS is that right there, 7x minus 19. Okay, so I need to kind of go through here. I want SRV, which is the whole angle. It gives me WRV, which is a part of that angle. And WRS, which is another part. But I know that those parts are divided by a diagonal. And that diagonal creates 2 equal parts. So this is actually a half and another half. Okay, so I'm going to use the property that diagonals bisect angles. Okay, so in order to solve for x here, because that's the only way I'm going to solve for the whole angle, I have to figure out what x is. I have to set these halves equal to each other. Okay, so we have 5x plus 5 equal to 7x minus 19. Subtract 5x. 5 equals 2x minus 19. Add my 19 to the left side. 24 equals 2x. 24 came from 19 plus 5. Divide by 2. X equals 12. So now that I know what x is, I can now go back to my question and see what it asked for. And it asked for the whole. Okay. So then I need to figure out how I'm going to get the whole if I'm only given the half. Well, there's two different ways. You can either plug it into both equations, so plug x into here and here and add them together, or you could plug it into one of them, so 5 times 12 plus 5, and then multiply your answer by 2. So we have 5 times 12, which is 60, plus 5, so 65. And then that is only half, so that means this angle right here is 65 degrees, but I want all of it. So because they're congruent, I know that this one is also 65. So 65 times 2 equals 130 degrees. Okay. All right, now on to squares. Okay, so we have properties of our square, and it's a little bit of everything in my eyes. Where it gets kind of complex is the diagonal. So if we look at it, we know that in a square, all four sides are congruent and that opposite sides are parallel. That's what makes it a parallelogram, with the opposite sides being parallel. We have the angles, 4 90-degree angles, something you have known for a very long time. And then consecutive angles are supplementary. And then last but not least, this is I think, where squares can get kind of complex, and that's the diagonals. They bisect each other, meaning they create congruent segments of the full diagonal. Diagonals are congruent to each other. They're the same size. They are perpendicular to each other, meaning when they cross, they create those 4 90-degree angles in the middle. So if I draw a little square right here, and I draw diagonals where they cross, create 90-degree angles. So that is very important to remember. And then the last one that's really important to remember, that diagonals are angle bisectors, meaning it splits. We go back to our square. It splits this angle in half. It splits this angle in half. It splits this angle in half. And then it splits this angle in half. Meaning, remember, all angles are 90 degrees. Meaning every angle that is split in half is now 45 degrees. So each angle in the middle when it's split in half is 45 degrees. And so on and so on. Okay, so let's do this example right here. So math is a square. And it says if MA is 8, what is AT? Well, the property that states that all sides are congruent, that would then make AT also 8. Okay. The measure of HST, so if we follow those points, HST, well, if we go back to our diagonal rule, diagonals are perpendicular. Okay, so when diagonals are perpendicular to each other, that means they create 90-degree angles in the middle. So then that would make HST a 90-degree angle. The measure of MAT, so it's this angle right there. Well, we know that every angle in a triangle is 90 degrees. So MAT is 90 degrees. And then we have MHS. So if we follow those points, MHS gets us this angle right here, MHS. So this is where the angle bisector rule will come into play. Diagonals are angle bisectors. So if we only want part of our angle, we know the whole angle is 90 degrees. So in order to actually solve for MHS, we have to take that 90 and divide it by 2. So 45 degrees is MHS. If HS is 2, what is HA? And what is MT? Okay. Well, HA, so HS is half the diagonal. And if we go to our rule up here about diagonals that says they bisect each other, meaning they create two congruent segments, that means SA, this part, is also 2. So if this is 2 and that's 2, altogether it should be 4. So HA is 4. So in order to find MT, we need to go back to our diagonal rule and look at this one. It says diagonals are congruent. So if diagonals are congruent, that would then make MT also 4. All right. MA is 8. MA is 8. What is HA? So if we erase the highlighters part, so we can kind of gather what we want. HA. We want HA. Okay, so this is where I wanted to add in this question because this is where Pythagorean theorem is going to come into play. If it gives us one side length, okay, and I'm going to kind of break it down over here. So MA, it gives us one side length of 8. It wants to know what HA is. Okay, so it wants to know this length right here. Well, there's two properties we're going to use. We're going to use that every angle in a square is 90 degrees, so we know that this is 90. Well, then that then creates a right triangle. Therefore, now we can use Pythagorean theorem. But some of you are saying, but we only know one side. We actually know both sides we need to know to use Pythagorean theorem. In a square, all sides are congruent. So that means this side is also 8. So in order to find HA, I'm going to use Pythagorean theorem. So we have 8 squared plus 8 squared equals C squared. So we have 8 times 8 fell on the floor, picked it up, it was 64. So we have 64 plus 64. So 64 plus 64 is 128, I believe. And then last but not least, you always should take the square root. And the square root of 128, I believe, is like 1 or 11 point something. 11.31. So the value of C is 11.31. Okay, and that's the value of HA. All right. Hope this helps.